Right here, and it says the function h of x is equal to x cubed minus 3x plus 2. Find the values of x for which h of x equals 0. So to do this, first thing we have to use is trial and error because we're solving for roots. We want to solve h of x equals 0, so we're solving for roots. So let's try, I don't know, let's try x equal 1, right? If x equal 1, what's going to happen? If we try x equal 1, we get 1 cube minus 3 times 1 plus 2. Yep, that is 0. And so x equal 1 works. So since x equal 1 work, then what we know is that x minus 1 is a factor of h of x. X minus 1 is a factor of h of x. Since x minus 1 is a factor of h of x, we're going to do our polynomial division. So x cubed minus 3x plus 2. We're going to do our polynomial division. We're going to divide x cubed minus 3x plus 2. We're going to divide it by x minus 1. Let's do the division. Divide it by x minus 1. Since we're dividing by x minus 1, x into x cubed, that goes x squared. X squared times x, that is x cubed. Then we have x squared times 1, that's minus x squared. Then we subtract them. Now, one thing I want you to notice, x cubed minus x cubed gone, but minus x squared become positive x squared. Then minus 3x minus no x becomes minus 3x. Then x into x squared, that's now plus x. X times x is x squared, that's x squared, minus x times 1 is minus x. And then we subtract it. And then now when we subtract it, we have minus 3x minus x, that's minus 3x plus x. Minus 3x plus x is minus 2x. Then we bring down this 2 now to have plus 2. Then we have x into minus 2x, that's minus 2. So we have x times minus 2, that is minus 2x plus 2. Then we subtract it. Subtracting it now, that will help us to find the roots. So the roots we're getting are, first thing we need to do is factorize this in the numerator, by the way. We need to factorize this. Factorize it. This is going to be x, 2, and 1. Signs are different, the bigger product positive, so this is plus, and this is minus. Yep, so that is h of x. So we can rewrite and say that h of x is actually equal to x minus 1 times x minus 1 times x plus 2. That is h of x. Since that is h of x, right? Since that is h of x, part A is done and dusted. So remember, we're rewriting h of x now as x minus 1 So that is what we get. We get x equal 1 and x equal negative 2. That takes care of part A. That is part A, of course. Now let's look at part B. Part B says to find the stationary points. To find the stationary points, we know we're going to have to do differentiation now. So part B, we have to do our differentiation. So h of x is equal to x cubed minus 3x plus 2. To find the stationary points, we're going to have to differentiate this. So what we're going to get is h prime of x is going to be equal to, when you differentiate x squared, we get 3x squared, carry down the power, subtract 1 from the power, minus 3. But guess what? At a stationary point, the derivative equals 0. So we can't forget that. At a stationary point, we know that h prime of x is equal to 0. So since at a stationary point the derivative is 0, what that does for us is we can set 3x squared minus 3 equals 0. Then we can bring over the 3, and so we're saying that 3x squared equals 3. And if 3x squared equals 3, then what we're saying is x squared equals 1. And if x squared equals 1, what we're saying is x is equal to 1 or x equal minus 1. That is what we're saying, x equal 1 or x equal to minus 1. Nice. So since that is what we're saying, x equal 1 or x equal minus 1, then all we need to do now is we need to find the corresponding y value. To find the corresponding y value, we plug 1 into this function up here. So to find the corresponding y value, what we're going to get is y is equal to, I'm going to use my calculator because it's going to be a little bit difficult for me to not use my calculator. So I'm going to plug in 1 up here. So it's going to be 1 cube minus 3 times 1. And then I have plus 2. So I work this out and I get 0. So this y value I get right here is 0 when x equals 1, y equals 0. Or when x equals negative 1 now, I need to realize what I get right here. So let me see what I get. So I'm going to plug it in now to see what I get now. So when I plug in minus 1 now, I'm going to get minus 1 cubed minus 3 times minus 1. Then I add that to 2. That is 4. So I get 4. So since I get 4, y equal 4. Now they ask for the stationary points. They don't ask for the stationary coordinates. They ask for the stationary points. And so we're going to have to tell them that the stationary points are you have to write them as coordinates. So the stationary points are 1, 0, and minus 1, 4. That's the stationary points. Then I already know what they're going to ask you next. They're going to ask you to determine the local max and the local mean. So to determine the local max and the local mean, you use the second derivative. So we use the second derivative, so the nature of stationary point. Nature of the stationary point. To determine the nature of the stationary point, as I just said, we use second derivative. Now, we're going to use the second derivative to determine the nature of the stationary point. And so remember that the first derivative we have right here is, all right. All right, now it's writing, so h prime of x, that is 3x squared minus 3. That is h prime of x. So we need the second derivative, which is h double prime of x, and h double prime of x is equal to, bring down the power, that is 6 times x, that is h double prime. Now that we have the second derivative, remember, what do we use second derivative for? H double prime of x. We need to evaluate the second derivative at these 2 points. And so let's start with at 1, 0. At 1, 0, we notice that h double prime of 1 is equal to 6 times 1, which is greater than 0, because that is 6. And so that means that 1, 0 is a minimum point. Minimum point. That's what we know. And so therefore at minus 1, 4, what do we notice? Minus 1, 4, the second derivative h double prime of minus 1, that is going to be equal to 6 times minus 1, which is less than 0. And so that is a maximum point. That is a maximum point. That's it. We have our local max and we have our local min. So now we can completely sketch h of x. So we need to sketch it showing. We need to sketch it showing the roots. We know the 3 roots. It cuts the x-axis at 1 and minus 2. We know where it cuts the y-axis, and we know the turning point. So as I always say, the easiest way to sketch these graphs is start by just drawing the curve. Let's draw a curve like this. Nice. Then as I always say, next thing you do is put on your stationary points. Maximum point is minus 1, 4. This is minus 1, 4. Minimum point is 1, 0. So you put this on 1, 0. Nice. Then you put on your axis. Put on your axis around it. That's easy. We know that when y equals 0, that's the x-axis. So this is our x-axis right here. This is our x-axis. And then our y-axis is going to be between minus 1 and 1. So the y-axis is somewhere right here. Then what else do we know? We know that this is the point 2, because we know the y-axis intercept. We also know that this is negative 2, because we found the 2 roots. Remember we said that the roots were, let me write it a little better. This is negative 2. This root is negative 2. This is the point negative 2, 0. We know this, and we know this is the point 1, 0. Nice and easy, soft. This is a diagrammatic sketch of h of x. Easy, soft. Now, just to verify that this is indeed true, you know, it's always good when we see it on a graph. So let us go to Geometer Sketchpad. Is equal to x cubed minus 3x plus 2. Here is the graph. As you can see right here, this is how the graph would look. I just want to show you the different points. This is a turning point right here. If I were to insert the point right here, this is the maximum turning point, just like what we got, right? This is the maximum turning point. This is the minus 1, 4 right here. All right, this is the minus 1, 4, just like what we wanted right here. We were to show this coordinate. This is the coordinate 1, 0, just like what we wanted, 1, 0. Then right here now, this is the y-axis intercept, and this we clearly can see this one is negative 2. So it's just like what we got, exact same. Nice. So this is the curve of how f of x look, which is just like our sketch. All right, see there, just like our one. Easy, soft.